In this video, we will show you how to calculate the magnitude and phase of a DTFT. Our signal for this video will be x omega is equal to 1 plus e raised to the negative j omega. First, let's start with the magnitude. One thing to keep in mind when finding the x omega magnitude is that the x omega magnitude squared will give us the same shape waveform with a change in the amplitude is all. Therefore, we can still get very useful information by taking the square of the magnitude. And it sometimes simplifies the way we find the magnitude. When we square the magnitude, we multiply it by the conjugate of a complex number. So for our example, we have the 1 plus e to the negative j omega times 1 plus e to the j omega. This will equal 1 plus 1 plus e to the j omega plus e to the negative j omega. From here we use Euler's formula and we get 2 plus cosine omega. While this equation might not seem like much, when we plot it, it will give us a lot more useful information, and we will plot it with MATLAB in our next video. So now we're going to move on to finding the phase angle of x omega. The phase is found by the tangent inverse of the imaginary over the real part. So with our equation of 1 plus e to the negative j omega, the one part is the inverse. The tangent inverse of 0 over 1. Plus the tangent inverse of negative sine omega divided by cosine omega. This all simplifies down to equal negative omega. In our next video, I will show how to plot these using MATLAB and explain more of their usefulness in a plot form.